Alright, here are a few examples of solving radical equations. What's kind of nice about this is it's just using your solving equations skills. And then the only new thing is they all have a square root, all these equations, and so we'll just have to figure out what the opposite of square rooting is. But when you solve a radical equation, you want to isolate the radical, or the square root. So if you look at this first example, you have a negative 2 times the square root of x. So that square root of x is the thing we want to get alone. Anything outside of that has to go to the other side first. So that negative 2 that's being multiplied out front, we'll go ahead and get that to the other side by dividing. So it leaves us with the square root of x equals negative 10 divided by negative 2 is a positive 5. So when we are solving equations, we always do the opposite. You know, we had multiplication, we just divided to cancel it out. Addition and subtraction are opposites of each other. Square roots and squaring are opposites of each other. So if you have a square root and you need to cancel it away, you will just go ahead and square it, and that square will cancel the square root. If you're going to square the left side, make sure you square the right side. So we squared the square root of x, leaves us with just the x, and then 5 squared is 25. So we solved the equation, we got 25 for our answer. Now the thing that you're not going to like about solving radical equations is we don't actually know if 25 is the true solution. The only way we know that is by actually checking our answer and plugging it back in to see if it works out. So we want to go ahead and zoom in a little bit. We want to go ahead, take a look at our original equation, plug in 25, and see if we get a negative 10. So we'll do negative 2 times the square root of 25, and the question is, does it equal that negative 10? Well, the square root of 25 is 5, and so if we do a negative 2 times 5, we get a negative 10, which does equal the right side. So it worked out. X equals 25 is our solution. But again, we don't necessarily know that until we check the answer to see if it works out. Alright, next example, moving over to the right here, we have the square root of x minus 5 plus a 5 equals 0. So isolate the radical, wherever your square root is. You want to get anything outside of that to the other side. So we have a plus 5 out front, or out back. We'll go ahead and subtract 5 to get that alone. So we have the square root of x minus 5 equals a negative 5. So we've isolated the square root. To undo the square root, well, first let me talk about this. Do you see how there's this minus 5 in here? It'd be great to add 5 to both sides to keep solving for x, but that minus 5, we can't touch that. It's trapped underneath the square root, and so until we undo the square root, we can't get to anything inside there. So to undo the square root, we'll go ahead and square both sides. So the square cancels out the square root. You're left with everything underneath, the x minus 5. And then when you square a negative 5, you get a positive 25. Alright, then we will go ahead and add 5 to both sides, and we get x equals 30. But does x really equal a 30? And that's why we'll just do our check, see if this one works out or not. So we're going to plug in a 30 for x, and then plus 5, and we want to know, will it equal a 0? So 30 minus 5 is 25, square root of 25 is 5, and then 5 plus 5 is 10, but according to our equation it should equal a 0. So here's what an example looks like where we got an answer. I mean, we did some great math here. There is nothing wrong with this math we did. We got x equals 30, but we plug it back in and it doesn't work out. So this x equals 30 is what we call an extraneous solution. It's a false solution. When you solve equations and you do this thing where you are squaring both sides, it can introduce false solutions into your equation. So because even though we got x equals 30, but when we plugged it in and it didn't work, that means our final answer will be no solution. But you do have to show that you solved for the x, you have to show that you plugged it in and that your check did not work. Alright, last equation to talk about for solving radical equations. So this equation looks a little bit different, mainly because we have two radicals to worry about. So what I do is I just pick one of them. I say, alright, I'm going to concentrate on this one. So I look to see, is there anything outside of that radical that has to get to the other side? Anything, because we want to isolate the radical. Because there's nothing, we can go ahead and square the radical, because the square will undo the square root. Well, if you're going to square the left side, you have to square the right side. So on the left, the square cancels the square root, and you're left with x plus 7. On the right, we weren't necessarily trying to do this, but we are squaring a square root, so it gets rid of that square root at the same time. It's kind of, two birds with one stone kind of a thing. So then what we're going to do, just keep solving. Let's get our x's together. We can subtract x from both sides. So we have 7 equals 2x minus 19. Let's go ahead and add 19 to both sides. 7 plus 19 is 26. And then divide both sides by 2, so we are getting x equals 13. But does x really equal 13? We don't know, so that's why we have to do our check and see if it works out. So when we check, you're going to plug x, or 13, into all the x's in the equation, and you're just going to see, does the left side equal the right side? So we have the square root of 13 plus 7. We want to know, does that equal the square root of 3 times 13 minus 19. Alright, well 13 plus 7 is 20, so I have the square root of 20. I want to see if I get the square root of 20 on the right side. 3 times 13 is 39. 39 minus 19 is 20. So I have the square root of 20 on the right. It worked out, so that means that x equals 13 is the final answer. So solving radical equations, isolate the radical, a square will undo your square root, and then check your answers in the end.